So E. coli is a type of bacteria that is commonly found in human, animals, and the environment around us. While most of the time they're harmless, they can make you sick and sometimes cause issues like traveler's diarrhea, urinary tract infections, and respiratory illnesses. But even if you got a relatively serious case, antibiotics such as ciprofloxacin can easily help you. However, there is a growing issue that is seriously limiting our ability to treat these infections with antibiotics, and that is antibiotic resistance. It happens when bacteria develop this ability to defeat the drugs that are designed to kill them. In fact, since 2019, ciprofloxacin was no longer recommended to treat traveler's diarrhea in England because of this growing resistance against it. And in the US, resistant E. coli infections have been growing by 60% for the past decade. So the most important driver of antibiotic resistance is the exposure to antibiotics among bacterial population. So the prudent use of antibiotics is the key to slow down this expanding issue. However, we're not doing great, because in fact, more than 70% of antibiotics in the US are not consumed by humans, but by animals, and including those types that are important to treat human infections, like ciprofloxacin. So how is that impacting our health as humans? This is where my study comes into play. I utilize whole genome sequence data from over 50,000 E. coli samples from across the US to examine the geographic patterns and trends of antibiotic resistance. For example, we identified hotspots in various states including California, Texas, Alabama, etc., and vastly different growth rates of resistance in diverse geographic areas. More importantly, I can utilize genetic data to reconstruct the evolutionary connections between bacteria found in both humans and animals. If bacteria found in different hosts are closely related to each other, then we know that they're jumping across the species barriers very easily, so we need better biosecurity measures to limit our exposure to these animals. Finally, we can utilize these information to give heads-ups to clinicians and veterinarians and, for example, say, hey, we're noticing a lot of resistance against this certain type of antibiotics in your region, so maybe you should consider limiting your prescriptions to your patients or animals. So with better understanding of the mechanisms and better guidance for usage, we can help resist antibiotic resistance. Thank you.